Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 90s on the screen. See how you do with that. It shouldn't take you long. Copy and go, please. All right, check with the neighbor, see what they got for the warm-up so we can get this on the road. All right, number one, what's your standard equation for that circle, Fabian? The standard form equation for that circle? That is correct. Check your work, please. And with that, we can get our center for the circle and the radius for the circle. What's our center, Lorena? 6 and -5, that is correct. And the radius? 4, that is correct. So when you plot that at 6, -5, sketch a point on all directions. That's how you get your circle. Number 2, what'd you get for the sum, Alyssa? Five plus I, that is correct. All right, how about difference? Julian, what'd you get for the difference? Plus 5I. Hands, have we got that? Looks about right. Product. What'd you get for the product? Alexandra. Alexandra, what'd you get? All right, help her out, please. Briseida. That is correct. Hands, have you got that? All right. Let's go to factors. Factor by grouping, number 3. Dylan, what'd you get? That is correct. Let's go. So far, so good. Number 4, graph. The parent function is like this, going through 0, 0. Where are we going to move that to? What would be our new vertex? Our new vertex, Christina. -4, -5, so that means we're going to end up somewhere down here. However, what do we do with this, Christina? Yeah, invert the parent function first, and then move it to that spot. Hands, have you got that? Let's go. And number 5, what'd you get for number 5? Solution. Anaya. What is it? 5 1/2. Hands, have you got that? That is correct, by the way. Let's go. And what method did you use? Substitution or elimination? Yep. All right. Copy the agenda for today. We got warm-up number 90, systems of equations in 3D. Oh, yeah. Yeah, you got to hold on to your horses today. Let's go. And home plate for tonight, pages 216 and 217. It's already in Canvas. Once you copy the agenda, go to Canvas, turn in your home plate. We have a signed screenshot. We also have the 12 problems from last night. And I think that's it. And in there you'll find the home plate for tonight. But I did leave it open till the end of the day, till 3:25, both things. So just to get us started with our lesson, do that at your own leisure. Get a Cornell note ready, please. You won't need a prayer model. And I'll give you some time. Set up your Cornell note, please. And for today's session, you will need your colored pens, all 4 of them, 4 different colors. And if you have highlighters, get highlighters as well. You need at least 2. If you want to borrow at least 1, there's some over there on top of the iPad cart. Just to keep organized today, got a lot of processes packed into this little itty-bitty problem. So, all right, here we go. I can solve 3D systems of equations. I can solve 3D systems of equations. So we've arrived to one of my favorite processes. It's so compact, but it's so kind of like a painting. It's really intricate but beautiful. You're like, what? You're going to see it right now. Anyways, 3D systems, we know what systems are, so we don't really need our Freire model. However, what kind of processes have we used for solving systems? We've used graphing, we've used substitution, and last night I gave you practice for elimination. Is that correct? Yes, Mr. Q. Today we're going to continue focusing on substitution and elimination methods. And just on passing the 5 different ways of solving a quadratic, there it is. We did some work with those kind of systems and so on and so forth. And if we were to apply it to a word problem, it would look something like this. Look up really quick. This word problem says a tour boat travels around an island. So imagine there's an island, and the tour boat is going around. Which equation do you think would be for the pattern of going around the island? Tell your neighbor, which equation would it be? Frida, which equation? Jessica? The first one, yes, because when the x and the y have squares, like on our warm-up, where was it at? This one, when we came up with the circle equation, which both have squares. Is that correct? Yes, Mr. Q. Anyways, so we can solve that kind of problem using what we know. And then it says, here's a tour boat going around the island, and it says that a sailboat, here's my sailboat, look at my art, it's coming, and they're asking, will the sailboat be in danger of collision with the tour boat? So what it's saying is that, is it going to intersect at any point that circle, or is it going to miss it? How do we know? Well, we need to solve this for y, make it into slope, intercept form, and then graph that to see if it's going to hit our circle. And how do we graph the circle? Using the center and the radius, and so on and so forth. But we're not going to do that. I'm just showing you where we can apply it. What I do want to get to is 3 dimensions. All right, there we go. Don't copy this. This is just so that you understand where we're headed. Imagine I gave you the coordinate plane that looks like this. Have we been working with those? Yes? Yes, Mr. Q. All right. Now, that coordinate plane has an x and a y value. That coordinate plane is in 2 dimensions. So if I was to ask you to use your paper, you make a big coordinate plane, and it's only 2 dimensions, length and width. But let's say I said, Alyssa, go up to the screen and push the y-axis backwards. And imagine she was like a superhero. She was like Power Ranger, and she pushed that. And all of a sudden, in midair, we see how the x stays in place, but the y fell backwards. You guys see it? Here it goes. It was like this. There goes Alyssa, pushes it with her superpowers, and bam! There it is. That fell backward. Do you guys see it laying back, yes? Well, guess what? What it does now, it reveals one more dimension, known as the Z dimension. Now, today, we're going to be solving for third dimensions, which means now our coordinates will be X, Y, and Z. So if I was to ask you to plot a point, pay attention, at 4 of X, 5 of Y, and 7 of Z, you would do this. 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So then I go to that spot and kind of like put my open point right there. So far I'm not done, because now I have to pick it up off the page and go how many steps up on Z? 1, 2, 3, 4, 5, 6, 7. That means I'm going to pull this up off the page, and it's going to be floating somewhere over here. Woo! Let's go! Let's go! Third dimension. But to get there, of course, I need to give you a nice little equation. So copy this one. Example number 3. The system of negative 2x plus y plus 3z equals 20, negative 3x plus 2y plus z equals 21, and 3x minus 2y plus 3z equals negative 9. Copy that. Okay, y'all ready? I told you guys to hold on to your horses. All right, here we go. Let me zoom in. Nice. So now we have 3 equations. And they're asking us to solve by substitution and elimination. Look up to the screen, write your utensils down. Focus, please. Here it goes. Write your utensils down. Everybody ready? Yes? All right, here we go. So, substitution. What does that mean, Mr. Q? That one of these equations we substitute into the other 2 equations. How do we know which one? Well, let's scan through this. Look up to the screen, or you're going to miss it. Look at the first variable. Are any of these x's by themselves without a coefficient? No. How about the y's? Yes, this one has the y by itself. How about the z's? Yeah, the second equation has a z by itself. So I need to make a decision. Which equation do I want to use to leave the y by itself, or the z by itself? You want to solve for z on this one or the y for this one? Me, I usually try and start with the y. So I'm going to rewrite that one by doing this. Leaving y by itself. I need to get rid of that. So what do? Add 2x and subtract 3z before you copy. Add 2x, subtract 3z to each side. So this cancels, and my new equation is y equals 2x minus 3z plus 20, the 20 right here. Copy that, please. So, if you notice, the first step was to make one of the equations equal to a variable, in this case y, and hopefully you remember from the work that we did with substitution method on the other ones, we needed to make one of them equal to y. Is that correct? So now we need to substitute this into these two. To keep organized, I'm going to highlight this bottom one in pink, and this second one in green. So which means I'm going to rewrite this one right here when I substitute that in there. And I'm going to rewrite this one over here to substitute that same one in that one. So here we go. I'm going to zoom in. So I'm going to take the green one, write it right here. Here it goes. Let's do that together. Negative 3x plus 2, and instead of y, what am I going to do? A big parenthesis, plus z equals 21. And what do I substitute in for y? Tell your neighbor, please. What do I substitute in for y? Yeah, 2x minus 3z plus 20. Let me zoom out. All right, so we did that for the green one, the red into the green. So now we need to do the red into the pink. So let's write the other one over here. I'm going to write 3x minus 2 parentheses plus 3z equals negative 9, which is this pink one. But again, instead of y, what am I going to substitute in there? That, the same thing. So let me zoom in again. I'm going to substitute 2x minus 3z plus 20. All right, so this is where we're at. So now that we did the substitution, this is called what? Substitution method? Yep. So now let's distribute. Let's start with the green one. Simplify it as much as we can. So I'm going to switch to blue. Here we go. I'm going to distribute this 2 into the parentheses. So I bring down the negative 3x plus 2 times 2x is 4x. 2 times negative 3z, that's negative 6z. And 2 times 20, that's 40. Bring down the z, bring down the equals, and bring down the 21. Let's continue. I'm going to switch to green to combine like terms. What is negative 3x plus 4x? 1x, yes. What is negative 6z plus z? Negative 5z. Bring down the 40, the equal, the 21. Last but not least, I want to leave this equation in standard form. What does that mean? Let's see if you remember. What does standard form mean? Tell your neighbor, please. Very good. Where both variables are on the same side of the equation. So we have x and z on the same side. What do I need to do to 40? Subtract 40. Subtract 40. So my standard form equation is x minus 5z equals negative 19. All right, simplify the other one by yourself. Go. I'll wait for you. All right, let's see. I'm going to use the same color. So I'm going to start with blue. So I'm going to distribute now the negative 2. Don't forget that negative in front of the 2. So I bring down the 3x. Negative 2 times 2x, that's negative 4x. Negative 2 times negative 3z, that's positive 6z. Negative 2 times 20, that's negative 40. Bring down the 3z, and all that equal to negative 9. Switch to green. Can I combine like terms? Yes, this is negative x. 6z plus 3z, that's 9z. Bring down the negative 40 equals to negative 9. To leave it in standard form, what do I need to do? I add 40, add 40. So my new equation is negative x plus 9z equals 31. Hands if you got that up to right there? All right, so let's go through our process just to make sure that we're following along. We started with a system of 3 equations, 3 variables. We solved one of the equations for one variable, which was the top one. We solved it for y, so we ended up with y equals 2x minus 3z plus 20. We used that one and substituted into the other 2 equations to keep organized. I did one in green, one in pink. We substituted in there, simplified, we got this. Now check this out. Look up to the screen. Why would we do that step? Because it makes all 3 equations smaller, and now we have 2 small equations. Look what I'm going to do. Look up to the screen. I'm going to write my first one. And then the second one. And some of you are like, oh, snap. Copy that. And tell your neighbor what you're going to do next after that. Zoom in. All right, guide me through this one or through the next steps. Let's see, Joel, what do I do next? Yes, combine them, very good. So therefore, x cancels, yeah, elimination. Uh-huh. $12. Let's solve for z. Divide by 4, divide by 4. Z equals 3. All right, tell your neighbor what to do from there, please. All right, good conversations. Pass someone, Joel. Sorry, the AC turned on. I can't hear you. I'm assuming you said to substitute into one of the 2 equations, yes? Which one, the top or the bottom? Top. So I'm going to write x minus 5, parentheses for z, equals negative 19. And I'm going to substitute 3 for z. So I end up with x minus 15 equals negative 19, plus 15, plus 15, x equals negative 4. All right, so let's see where we're at. Let me zoom out. They ask us to solve this system. For the system to be solved, let me write it up here, we need a big coordinate, and we need 3 values, x, y, and z. Do we have an x already? Yes, Mr. Q, that's negative 4. What else do we have? A z, which is what? 3. What are we missing? The y. So, oh my, what shall I do to find my y value? Tell your neighbor, please. Jose, pass someone. Who? Jalen, what shall we do? We have x and z. We need a y value. Help her out, Delilah. What's that? Substitute into which one? Delilah says substitute into the red one since this one already has the y right there. So yeah, let's bring this one down. I'm going to write y equals 2 parentheses for x minus 3 parentheses for z plus 20. So x is negative 4. Z is 3. And let's z what we get. Y equals negative 8 minus 9 plus 20. Negative 8 and negative 9 is what? Negative 17 plus 20. And that is what? 3. And that goes right there. And that is my solution. Woo-wee. Look at that beauty. Instead of being a Picasso, it's a Q-casso. Q-casso? Yes? Jessica, be nice. Oh, it's the pixelation and all that. From 1 to 5, I'll come to bar you with substitution and elimination combined. I got some 3s, 4s, 5s. 3s, 4s. All right. So, let's reflect back to last week and this week. Last week we did a lot of substitution methods. But what do you guys notice when we got to the elimination method? Wasn't it a lot faster? A lot faster, yes? Well, what if I told you that these could be solved a lot faster? So with that said, copy example 3 mega cube, which is the same system, but now we're only going to solve it using elimination method. Only elimination. Only elimination. That's a nice word, elimination. Reminds me of that movie, Forever. Forever. No, you guys don't know what I'm talking about. Forever. Oh my goodness. You guys should really yeah. Yeah, it's talking about the beast. Forever. Anyway, so we're going to solve this same system, but only using elimination method. Okay? So here we go. Y'all ready? In order to solve this using elimination method, let's reflect to yesterday and your home play, the extra practice that you did by yourself. What needs to be met in order to eliminate a variable at the beginning? They need to be opposites. Is that correct? All right. So start off by looking at the x's. Look up. Can we eliminate any of these? Yeah, the negative 3 and 3. Don't do anything yet. Don't highlight either. I'm just showing you something really quick. But can we eliminate that one? No. Okay, so we can't use x right now, because even if I try to multiply this one times something, it's not going to give me 3. So we can't eliminate x. Okay. Let's go to y. Look at the y's. Can we eliminate these y's? Can we eliminate that one? Unless we do what? Multiply this entire thing times what? Times 2. So that one is, there's a possibility there. Okay, not bad. Let's look at the z's. Can we eliminate the z's? No, unless I do what? Multiply this one times what? Negative 3. So here you need to make a decision. Either I eliminate the z's, multiply this one times negative 3, or I eliminate the y's and multiply the top one times what? Times 2. So let's see, we're going to ask Jaden. Jaden, which variable would you like to eliminate? The y or the z? The y, okay. He says y. That means, check this out, look up, guys. That means that I need to use this y that has a negative twice. Here and here. And then this one, I'm going to highlight in green, goes here. And the top one, we need to multiply times what we said? Times 2, and that goes right here. So let's do that top one and write it right here. So 2 times negative 2, that's negative 4x. 2 times y, that's positive 2y. 2 times 3z, that's positive 6z, equals, and 2 times 20, that is 40. The pink one underneath goes right there, 3x minus 2y plus 3z equals negative 9. All right, I'm going to rewrite that here, 3x minus 2y plus 3z equals negative 9. And the green one, this one is negative 3x plus 2y plus z equals 21. All right. So, we're using what method? Elimination. So with that said, I'm going to start with these two. Pass someone, Jaden. Who? JP, tell me what to do. Negative x. 9z. Thank you. We can't do anything else with that. Let's go to the next one. Pass someone, JP. Juan. Cancel out the x's. Cancel out the y's. What? Uh-huh. All right. Can we solve this little equation? Might as well. Yeah. Divided by 4. Z equals 3. Oh my. What shall I do with that z? Tell your neighbor, please. Yeah, substitute it into this one. So I'm going to write negative x plus 9 parentheses equals 31. Instead of z, I substitute 3. So this gives me negative x plus 27 equals 31. From there, subtract 27, subtract 27. We have negative x equals 4. And last but not least, divide by negative 1. X equals negative 4. We need a y value. Tell your neighbor which one you're going to use to get our y value. All right. Alyssa, which one? The top one? You mean the blue one, or the pink one, or the green one? The blue one? Okay. Does it matter in this case? No, because none of them is solved for any variable, so I'm just going to bring this one down and write negative 4 parentheses plus 2y plus 6 parentheses equals 40. We substitute negative 4, 4x. We substitute, I'm going to use green for z so I can see it. There it is. All right, let's see. This is 16 plus 2y plus 18 equals 41. Combine like terms. So that gives me 2y plus 34 equals 41. Is that correct? Oh, 40. Oh, I did that to see if you were paying attention. 40. Okay. Continue. Isabella. Uh-huh. So we end up with 2y equals 6, and then divide by 2, y equals 3. Solution for this one, start with x, which is negative 4. Y is 3, and z is 3. Check and see if we got the same answer since it's the same system. Did we get the same answer? Yes. You're like, what? So let's see, show of hands. Who likes substitution method better? Who likes elimination better? Yeah, it's a lot faster, right? Seems to make a little bit more, it flows a little bit better. All right, now check this out. In this case, it was nice that here, look up to the screen, it was nice that here, both variables eliminated. But most of the time, that's not going to be the case. So what happens if we end up with 2 variables here and 2 variables here? Then we have to make a system and then solve that system. Does that make sense? Yeah? All right. Copy this one, please. Example 3 super Q. We got x plus 2y plus z equals 8, 2x plus y minus z equals 4, and x plus y plus 3z equals 7. So let me go one step at a time. Look at the x's. Can we eliminate any x's? Look at them. No. However, in order to eliminate this one with this one would have to be what? Negative 2. But then this one have to be positive 2, so there's too much to do. All right, so not the x. Let's see. Move on to the next one. Can we eliminate the y? No, that means still we will need to multiply 1 times 2, 1 times negative 2. Okay. Can we eliminate the z? Not at that point. However, what does this need to be? 3, and this one positive 3, this one negative 3. So my question to Jaden, which variable would you like to eliminate, Jaden? Y, x, or z? Which one? X. All right, Jaden said he wants to eliminate x, which means this one we need to multiply times, let's make this one that we multiply times negative 2. And the top one times positive 2. So let's multiply the negative 1 down first, so we can write it twice. So our new equation is negative 2x, negative 2y, negative 6z equals negative 14. See? Did I distribute correctly? Yes. Let's write it again. Negative 2x, negative 2y, negative 6z equals negative 14. Why twice? Because now we need to write this one right here and the blue one over here. So let me write this one right there. 2x plus y minus z equals 4. And the blue one, distribute. 2x plus 4y plus 2z equals 16. All right. Let's see. Jaden, pass someone so they can help me. Who? Ivan. Go. Help him out, Caleb. X cancels out. Negative y, okay. Negative 7z. Negative 10. All right, so far so good. Diego Rosas, continue with the other one. Cross out the x. Two y. Negative 4z. Two. Positive 2, yes? All right. What do you guys notice? Did we eliminate two variables on this one this time? No. So we end up with two equations. So what shall we do with those? Make a system. Negative y minus 7z equals negative 10. 2y minus 4z equals 2. All right. What shall I do there? Tell your neighbor before I call on Jessica. What shall I do there? Jessica, what shall I do? Multiply the top one by 2. That is correct. So that gives me negative 2y, negative 14z, and negative 20. Okay. So this cancels. We're left with negative 18z equals to negative 18. Let's solve. Negative 18, divide both sides. Z equals 1. Continue. Isabella. Substitute into which one? The black one or the red one? The red one. Okay, so let's rewrite that. Negative 2y minus 14 parentheses equals negative, let me make a little bit of room here, negative 20. And I'm going to substitute 1 there for z. So this becomes negative 2y minus 14 equals negative 20 plus 14 plus 14. Negative 2y equals negative 6. Divide by negative 2. Y equals 3. And last but not least, do we know what to do with those two values? Yeah. Alyssa, which one shall we substitute that into? The green, the red, or the blue? Which one? The green, okay. So I write 2x plus y minus z equals 4. Substitute the values in there, and that's how you get your your x, and the rest is history. I'll stop the video right here. Good one, guys. Enjoy your home plate. See you guys tomorrow. Bye. I know, right?